Assalamualaikum warahmatullahi wabarakatuh and good evening. We are from Group 5 and we'll be presenting industrial turntable for our project for subject control engineering for our group assignment. Our group member consists of 5 people, which are Shahri, Nurul Alia, Nurul Zakira, Muhammad Zu Imran, and Karinisa. Turntable are often widely used in industrial sector for automated manufacturing lines and positioning. The device function in accordance with the speed, direction, and desired angle that are selected. Turntable have been using in a variety of application, including power turntable, pallet turntable, power rotating turntable, and more. In this application, the angular speed is the control variable. Mostly used as a rotary turntable for packaging, also known as a pallet turntable. This turntable rotate the wrap of the packaging according to its operating principle. The motor turns the turntable at constant RPM. The tachometer, which measure the motor rotational speed, also controlling the speed. So the figure above shows the detailed layout of turntable speed control system. Meanwhile, the figure below shows the block diagram of turntable speed control system. So for the objective, we have 3 objectives. First is to utilizing the information they have learned from the lectures. Students will construct a closed loop control system. Second is to carry out time domain, schematic diagram, transfer function, and mathematical model analysis among other type of analysis. Third is to examine the transfer function using Simulink and MATLAB, learn how to solve control engineering problems with equation using the MATLAB computer language. So for the scope, first is to finding out the essential response of a typical second order control system to step input is crucial. The technique for analyzing a control system functioning are time domain analysis and frequency domain analysis, and they are both applied in the same manner. Second is typical and standard test signal are used to assess how well a system operates and behave. In this instance, selecting control parameter will be required to meet transient response standard. Third is to analysis of the transfer function. A simulation in a computer aided software such as MATLAB is performed. MATLAB may be used to create either a closed loop or an open loop based on the data or input.
Assalamualaikum. My name is Nurul Zakira binti Rosli. My number matrix CD210079. Today, I would like to present about the literature review for our projects. Our group chose the industrial turntable for our literature review projects. Industrial turntable are utilized in the manufacturing and material handling, utilize a combination of the mechanical and electronic principles to facilitate the movement, positioning, and rotation of the heavy or massive object. Turntable optimize productivity, streamline productions process, and improve the workflow in the various section. Their drive system consisting of an electric motor, gear mechanism, and bearing ensure smooth movement required a robust constructions. Turntable circular platform control load or object in industrial applications. Turntable can classify as a standard duty and heavy duty. They have ring, bearing, capacity. Turntable can standard duty turntable offer a cost effectiveness in industrial application, while the heavy duty ring bearing turntable offer the precise positioning, increased capacity, durability, and increased stability. Turntable platform classify into the regular and the reinforced type can be powered by pneumatic, air, or electricity, and some have moved leg and caster for easy transportation and weak balance. Industrial turnable have seven benefits. First, exchange efficiency. Second, space optimization. Third, exchange workflow. Fourth, reduce labor intensity. Fifth, improve precision and control. Sixth, reliability and durability. Lastly, space saving. Working principle of the turntable process control. In industrial, turntable is a machine used in the manufacturing material handling, combining the mechanical and electrical principle to move the position and rotate the heavy object. It optimizes productivity, streamline the process, and improve the workflow with the electric motor driving the spinning. In our project, we have three terms. Uh, First, control. Second, application actuator. Third, process. In control, we using the amplifier. Second, actuator, we using the DC motor. And lastly, process, we using the turntable. Review on the control system component in digital tachometer. Okay, in the digital tachometer, we have three is optical sensing, inductive sensing, magnetic sensing. Mechanical flyball. The mechanical flyball is a educated velocity measuring the device use the speed governing system for the engines and a turbine. It functions as a both control actuator and measuring instrument with the linear output and the normal measurement error plus minus 1%. The device consists of the two spherical ball rotating on a spinning shaft which move outward due the centrifugal force and lift a pointer against a spring resistance. The pointer can be set up for the visual speed educations or translate into the electrical signal.
Assalamualaikum and salam sejahtera to Dr. Ram Huzaini. My name is Syaril bin Narjale. My matrix number is CD210071 and I will present about the theoretical calculation and analysis of open loop and closed loop system. Mathematical model for turntable. For this system, the controller is PID controller, the actuator is DC motor, the process is turntable, and the sensor is tachometer. This is the block diagram of the turntable with the transfer function of controller, actuator, process, and the sensor. Transfer function for this system is GCS multiplied by GS divided by 1 plus KT multiplied GCS multiplied by GS, where GCS is the PID controller and GS is the actuator and process. Analysis of open loop system, and this is the block diagram of this open loop system where it only have the actuator and the plant. From the block diagram of open loop system, we can reduce it by using the cascade method, and we can get the new transfer function in a single block. After we get the transfer function, we can substitute the value by using the parameter given. This is the final block diagram of open loop system. From this transfer function, we can determine the step response, root locus, and port plot by using the MATLAB. For closed loop system analysis, our main goal is to find the Kp, Ki, and Kd values on the PID controller. This value will affect the stability of the system by referring the graph. We use the MATLAB software to generate the Simulink based on the block diagram for the closed loop system. This is the block diagram for the closed loop system. From the block diagram, we convert it into the Simulink on MATLAB to determine the value of Kp, Ki, and Kd. Kp is the proportional, Ki is the integral, and Kd is derivative. This value will be tuned to get the stable system. To find the value Kp, Ki, and Kd, we're using the trial and error method. Simulink is utilized to find the stability system for closed loop system. The time it takes for the system to reach complete stability will be displayed graphically by Simulink. A stable system will be achieved by aligning the value on the PID controller. This is the graph for the closed loop system when the value of Kp, Ki, and Kd will start at 0. First, we will determine the value of proportional P or Kp with increasing the value until it gets the best graph. There are three tests will be conducted to determine the best value for Kp. The value of P will start at 1, 5, and 10. This is the test 1 where P equal to 1. It takes a long time to achieve the stable system. This is the graph for the test 2 where P equal to 5. The time taken to reach the stable system is shorter compared to test 1. This is the graph for the test 3 where P is equal to 10. The time taken to reach a stable system is shorter compared to test 1 and test 2. From the all tests, we can see when value P is equal to 10, the time required by the system to reach a stable state is getting shorter. After this, we will see the effect of proportional plus derivative, where the value of P is equal to 10. There are three tests will be conducted to determine the best value for derivative. And derivative value as shown in the table below. This is the test 1, where the value of derivative d is equal to 0.1. And this is the test 2, where value d is equal to 0.0001. And this is the test 3, where value of d is equal to 5.05 multiplied by 10 power of negative 7. From the all graph, the best graph is when d equal to 5.05 multiplied by 10 power of negative 7. The line output almost parallel to the step input line. Lastly, the effect of P plus D plus integral I. Integral value as shown in the table below. This is the test 1, where the value of I is equal to 1. If we look closely, the output line overshoot the step input line. This is the test 2 where the value of I is equal to 0.1. This is the test 3 where the value of I is equal to 0.000419. From the all graph, the best graph we get is when I equal to 0.000419, where the line output almost parallel to the step input line.
Assalamualaikum. My name is Nurul Alia binti Muhammad Jazmi. My chemistry number is CD200127. Today I will like to present my part, which is result and discussion. The first one, we go to the result. The process of obtaining proportional, integral and derivative value by try and error allow one to determine the ideal value of creating stable graph. As a result, P, I and D have a value shown in this table. P equal to 10, I equal to 0.000419, D equal to 5.05 exponent negative 7. Based on the value, the resulting graph is shown in this graph by using the suitable value for PID controller. Next, what we can see in this slide, they have a two graph, which is the clearance between the step input and output. Next, we go to discussion. This is the plot diagram of turntable. To get a stable system for turntable, the value of Kp, Ki, and Ks, Pi, and D are adjusted using MATLAB software. As a result of the process of try and error, the appropriate value can be obtained. The new value of a Kp is 10, Ki is 0.000419, and Kd is 5.05 exponent negative 7. As a result of this trial, there are several things that can be discussed in relation to PID value. First, the effect of the value proportional P. As the value get bigger, the time it takes from the system to change from transient to the steady state is accelerating. The time required by this system becomes shorter. This graph shows that time difference is take from the system to be stable. The first graph is P equal to 1. The next of the graph is P equal to 10. The second one is the effect of value integral I and derivative D. The smaller derivative value, the smaller the clearance between the step line input and the output line. This graph shows evidence that this statement is true. The first graph is I equal to 0.1 and the second one is I equal to 0.000419. This is have a different smaller value I. Next, we go to the effect of value derivative D. The first graph show D equal to 0.1 and the second one is D equal to 5.05 exponent negative 7. What we can see in these two graphs, the smaller derivative value, the smaller the clearance between the step input and output line.
In summary, a speed control plays a critical role in many different sectors by guaranteeing the dependable and effective operation of equipment. In many different applications, enhanced performance, accuracy, and safety have been made possible by the invention and application of sophisticated speed control technology. The capacity of temporary speed control system to change in real time to maintain speed under changing circumstances in one of its fundamental features. This flexibility is essential for increasing process efficiency, cutting energy use, and prolonging equipment life. The use of digital technology, including sensor and microcontroller, has made it possible to provide more accurate and complex speed control, enabling responsive and fine-tuning. In addition to improving the machine general performance, this also helped to lower downtime and boost productions. Moreover, speed control systems are essential for maintaining safety since they guard against equipment overload, guarantee adherence to operating limitation, and make emergency shutdown easier when needed. This is especially crucial in sectors like manufacturing, transportation, and healthcare, where accuracy and dependability are critical.